Let's start with the most basic type of factoring, and that's looking for a greatest common factor, or basically reversing or undoing distribution. So remember, factoring means to undo some kind of multiplication. To undo a distribution, we're going to look for something that was common in all of the terms, because that was originally distributed through. So in the example from earlier, we had 3x plus 6. 3x plus 6, if you look at both of those terms, they both have a common 3. Common factor of 3. A 3 would divide in evenly to both of those terms. So the idea is to take the 3 out and then write what you would have left if the 3 was undistributed. So basically divided. So 3x divided by 3 is x, and 6 divided by 3 is 2, so you're left with an x plus 2 here. Let's try that with another example. Here we have 3x squared plus 5x. If we think about factoring that, what we want to do is look for something that's in both terms. The 3 and the 5 don't have anything that is common that you could divide into both, but both terms do have an x in there. That means x is common, so we can divide it out of both. To do that, we're going to undistribute. We're going to take the x out and in parentheses leave what would be left if we took it out of each term. 3x squared divided by x would be 3x. 5x divided by x would just simply be 5. So we undo the distribution of x. And a perfect way to check this, and you should always notate a check by saying check or use a check mark, is to distribute this back through. X times 3x, if we distribute, would be 3x times x, or x squared, and then x times positive 5 would be positive 5x. So you distribute back to see that it does work. So this would be our final answer right here in the factoring process. Let's look at 3 more examples. 6x cubed plus 18x. If we start with the numbers, 6 and 18 both have a common 6 in them. But they also have, if we look closely, a common x. So let's take out that common 6 as well as x. To take it out, we'll put it out in front, and in parentheses, we're going to leave what would be left if I take it out of both terms. 6x cubed divided by 6x would be x squared. 18x divided by 6x would be plus 3. So if I've done this pulling out correctly, that should be my final factored answer. To do this, to see if it's right, we check by distributing through. 6x cubed is what we'd get if we have 6x times x squared plus 18x. A good strategy when you're checking is to cover up where you started, because your mind may try to force you back to where you started. So cover up that initial line and just see if you really get where you started when you do the distribution. In this middle example, the 4, the 6, and the 2 all have a 2 in common. And then look for variables. They all have an x in them, so we can take an x out. This time, there were 3 terms that we were looking for common factors in. So I'm actually distributing the 2x out of 3 terms. So I'm going to have 3 terms left here. So notice my parenthesis is a little bigger. 4x cubed divided by 2x is 2x squared. Negative 6x squared divided by 2x is negative 3x. And then 2x divided by 2x is positive 1. It's a very common mistake to leave off that plus 1, but you can always catch it if you do leave it off by doing the check. Because say you left off that positive 1 there. If we go to check that, so if I had left this off, if I go to check this, if I had multiplied the 2x through, 4x cubed minus 6x squared, and then if I didn't have anything else to multiply, I wouldn't get back to where I started. So I do need that positive 1 there, because anything divided by itself is a positive 1. So I do have to have this in order to get it to distribute correctly. So there's that 2x, and now it matches up. So don't forget, anything divided by itself is 1. In our last example, we have 12xy squared plus 16xy minus 8x. There is a 2 in common with each factor, each term, I should say. But one thing to keep in mind is we always want to take the biggest. That's why it's called the greatest common factor out. The biggest wouldn't be 2. It would actually be 4. 4 will go into 8, 16, and 12. You might try 8, but 8 won't go into 12. So 4 is going to go in. There's an x in every term, but there's not a y in every term. So I can't take a y out, just the 4 and the x. Now, in your parentheses, leave what you would get when you take that 4x out or divide it out. 12 divided by 4 is 3. The x's cancel out, and we get y squared. 16 divided by 4 is 4. X's again cancel out, and we get left with a y. Minus 8x divided by 4x. The 8 and the 4 divide out to give me 2, and x's cancel, so we just have a minus 2 there. If we check, 4 times 3 is 12, x, y squared. 4x times 4y is 16, and keep the x and the y. And then 4x times negative 2 is negative 8x. And now I check to see if I'm where I started, and I am, so that checks. So this is the correct factorization.